Hi mathematicians, welcome to chapter 4. We are now going to start talking about second order diffie-qs. And honestly, some of you are really going to enjoy this transition, and I think some of you will start to get your stride about what's going on here with this differential equation situation here. But basically, what we're going to have now is a second order derivative. Before this, we only had first order derivatives, right? We had a dy dx. But we had like your y prime, right? But we didn't have a y double prime. And so that's now what we're transitioning to, is a second order. There's going to be two methods that we're going to talk about for solving second order. And so the second method, using eigenvalues and eigenvectors, that's after this. Okay, so if you see videos on the web about eigenvalues and eigenvectors, we're going to get to that, but that's not what we're doing now. Okay, so don't look at those videos just yet. But again, I think you're going to like this. So here's our second order linear equation. Again, it's second order because it's a second derivative. It's linear because I have my second derivative, my first derivative, and just my y, and they're not doing anything goofy, right? This isn't a y squared. This isn't a y times a y prime or anything like that, right? So, and in this instance over here, you might have some function. But when we're talking about homogeneous equations or homogeneous equations, I don't know which it's pronounced, on the right-hand side is always going to be equal to 0. So we're always going to have an a y double plus b y prime plus c y equals 0 on the right-hand side, okay? So this 0 makes it a homogeneous or homogeneous. Beth doesn't know. She also often refers to these as milk equations, just because she doesn't like saying homogeneous or homogeneous. So that might be a question on the weekly check for you to tell me, why does Beth associate homogeneous with milk? That'll be on the weekly check. Okay, but I might refer to them as milk equations from now on. All right, and so let's go ahead and investigate this equation, because the idea, remember, what we're looking for is we're looking for some function that when we plug it into this equation, it's true, right? So imagine I go and I solve for this y double prime. If I solve for this y double prime, and I go ahead and I subtracted, right, this by prime and the cy from both sides. So I subtracted from this side, I subtracted from that side, and I have a y double equals negative by single minus cy, and then I went ahead and I divided by a. We get y double equals negative by single over a minus c over a y. This is saying this sentence or equation tells me that the second derivative is a combo, right? Combination, combo for short. We okay with that? I hope so. Is a combination of the first derivative and the original function. I'll put original function. Okay, what did I just say? All right. Okay, so this sentence or equation, my or isn't really separate from it either, tells me that the second derivative is a combo of the first derivative and the original function. We have y double equals y single and the original equation, right? With some combination of coefficients in front of it. What kind of function resembles itself every time you take a derivative? Right? That's what we're looking for here. Right? Because if we think of something like, imagine our original equation was x squared, y single is 2x, y double is 2. I definitely cannot write 2 equaling some combination, right? I'll even put a C1 times 2x plus C2 times x squared, right? This isn't going to happen unless these are both 0, right? So this is definitely, a polynomial is definitely not the kind of function we're looking for. What kind of function am I looking for? Y. Let's choose y equals e to the RT. Is this a good function to deal with? Let's see. We get y prime. What is y prime here? Y prime is r e to the RT. What is y double? Y double is r squared e to the RT. Let's go ahead and plug it in and see if it can make this equation true. All right? So I'm going to have an a times r squared e to the RT plus b times r e to the RT plus c e to the e to the RT equals 0. I'll give you a second to write that down. You should be, I hope, you are consistently taking notes as you look, right? Because it's helpful for your brain. We're just trying to get you to learn here. So, and differential equations are so cool, guys. This is it. Like, this is what you've been taking all this other math for, in my opinion, is for differential equations, right? All this applied math we make you take, there's like differential equations is so cool. Okay, so I have this situation. You've been in this situation before. When I ask you to find roots of polynomials, you have something on the left-hand side, typically. You have 0 on the right-hand side. And I ask you to factor. We're going to do the same thing here. Notice I have this e to the RT, e to the RT, e to the RT. Let's go ahead and let's kick that out front. So we have e to the RT times AR squared plus BR plus C equals 0. Amazing. Okay? Right? You've been here before. So typically, what do we do here? We're like, well, then e to the RT has to equal 0, or AR squared plus BR plus C has to equal 0. But guess what? Never true. E to the RT can't equal 0. E is a value, right? It's a number, right? You're raising a number to anything never equals 0. So we just get to ignore that left-hand side, and we get to go ahead and solve this for R. So you get an R1 comma R2 equaling negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so yeah, you're gonna treat the, sometimes you just get to factor it, right? Sometimes they'll be real and distinct and you can factor it. Sometimes they'll be real and repeated and you can factor it. Sometimes they'll be complex and you're going to use your quadratic formula. All right, but regardless, you're going to get to ignore this guy. this guy is now a polynomial, right? Instead of x, we're in terms of r here. And then from here, let me move this down. Someone this weekend convinced me to get an iPad, so maybe I'll get an iPad before the end of the semester and I'll take my notes on there. I don't know. I'll try to get into this century. So now that we find out what R1 and R2 is, okay, we now have two solutions. We now have two solutions. Okay, one of them, y1 of t, is going to be c1e to the r1t. y2 of t equals c2e to the r2t. Either one of these will solve this, our original equation way up here. Either one of them will solve this, okay? And we write the general solution as a combination of them both. So our y of t equals c1e to the r1t plus c2e to the r2t. And that is your answer. Fantastic. Okay, for right now, believe it or not, real, distinct, what does it mean to be distinct? That means they're different. Real, distinct, and complex are easier than real repeated. So real repeated will be next. Okay, but for right now, you're going to do real, distinct, and complex. And this is how you're going to solve them every single time.